Hey, how's it going, guys? I hope you're all doing well. My name is Taha. Welcome back to another day of the 30-day League Code Challenge. So today's question is called Distribute Candies to People. Let's read the description here. So we distribute some number of candies to a row of n people. Then we give one candy to the first person, two candies to the second person, and so on until we give n candies to the last person. Then we'll go back to the start of the row, giving n plus 1 candies to the first, n plus 2 to the second, and so on. This process repeats until we run out of candies. The last person will receive all of our remaining candies, not necessarily one more than the previous gift. Okay? And we'll return an array whose length is the number of people that we have, and summing up to the total candies that we've given out. This represents the final distribution of candies. Now, as usual, before I jump into the code, I want to just kind of break down my thought process on paper and show you guys how I approach this problem. So let's get to it. As you guys might have noticed in my previous videos, I usually like to start off with a piece of paper and a pen and just figure out how the logic works in the problem that I'm trying to solve. And just see also kind of the different variables that are involved and what needs to be changed throughout the algorithm. So the example that I want to start by looking at is, let's say we have n equals 4 people, and the total I'm going to use TC to represent total candies. Let's start off with 9 of them. All right. So I'm also going to initialize a variable for the number of candies that we've given out. And I'm going to call that G for given and start that at 0. So I want to look at what our array looks like in the beginning. So it's 4 people and no one has any candies. And again, our total candies is 9. Now, what I'm thinking to myself is I want to figure out how total candies changes and also look at how our row of people changes as we give candies. So let's see here. Let's start off by giving 1 candy. Once we give 1, our total candies is going to go down to 8. And our array of people will look like this, right? Let's give 2 candies now. Our total candies will go down to 6. The second person gets 2 candies, right? The third person will get 3 candies. And our total candies will be 3. So now we have 1, 2, 3, 0. Now we're trying to give 4 candies. So here we're trying to give 4 candies, but we actually only have 3 remaining. So this is one of the reasons why I like to work things out on paper, is because you catch cases like this. So again, now we're at a point where we're trying to give more than what we have. So in this case, instead of giving 4 candies to the 4th person, we're going to give total candies. So all the candies that we have remaining are going to go to this last person. And our total candies will now be 0. So let me put in writing the logic that I'm going to be using. So the main idea here is we're going to keep giving candies while our total candies minus our given is greater than 0. So in other words, what this means is keep giving candies as long as the amount that we're trying to give doesn't turn our total candies negative. So let me repeat that. Keep giving candies as long as our total candies doesn't go below 0, because we're not able to give negative candies, right? So if we do get to a point where the amount that we're trying to give is more than the amount that we have, what are we going to do? So what we'll do is, if the amount that we're trying to give is more than what we have, then we're just going to give all that we have. So in this case here, we were trying to give 4, but we only have 3 remaining. So in this case, we just gave all 3. All right, so this is the basic logic that we're working with. And let's take a look at what this looks like in Python. All right, so here I have our basic code and set up for the distribute candies function. We're going to take in some number of candies and some number of people. So let's first initialize a variable to represent all of the people that are in our group. I'll just call this variable group. And first we're going to start off everybody with no candies, and we'll multiply this by num people. So this will give us a list that has the length of the number of people that we have, and everybody's going to have 0 to start off with. Let's also represent the variable that holds the number of candies that we're going to give out. Initially, we'll start with 1. So I also want a variable to keep track whether we have candies left. And when we start that off, we're going to set that to true because we start off with enough candies. The question does guarantee that we'll have at least one person and one candy. So now we want to say, while we have candies left, we're going to keep giving candies. So again, while we have candies left, keep giving candies. Now, how do we do that? I've said the word candies way too many times in this video, getting tired of it. But let's go through and loop through all the people that are in our group. So for person in group, actually, we're going to need to keep track of the index. So let's say for I in range 0 to the length of group. Where's my autocomplete? Okay. So we're looping through all the people in our group. Now remember, one of the things that we figured out on paper is that while our total candies minus the candies we're giving out is greater than 0, we're going to keep giving out candies. So let's put that here first. If candies, which was passed up here as a parameter, minus give is greater than 0, we're going to give this person a candy. Or we'll say group at I goes up by give. Now we need to make sure we decrease candies by the number that we just gave out. All right. Now if this if statement is false, in other words, if we're trying to give more candies than we actually have, we want to make sure that we give this person all the candies that we have. So we'll say group at I, so this person is going to be increased by candies. And we say candies here because this represents the total number of candies that we have. So once this happens, we want to set have candies left to false. And also we want to make sure at the end of every iteration of the loop, we increase the number of candies that we give by 1. So let me just reiterate what we did here. We're looping through all the people that are in our group of people. Now this first if statement here checks if we give candies to this person, are we still going to have more candies left over? As in, is the number of candies that we have left going to be greater than 0? If that's the case, then we're going to give this person whatever we're trying to give them. And we'll also decrease the total number of candies by the amount that we just gave. After that, we'll increase the number of candies that we'll give by 1. And we'll keep going through this iteration until this case is not true. All right. When this becomes false, when we're trying to give more candies than we actually have in our possession, then we're just going to give this person all the candies that we have. And we'll set have candies left to false. And we also need to break here, because after this, we're going to go to our while loop, and this is going to be set to false. And we will exit. At the end, we'll just return group. And remember, group is just our list of people and represents how much candy each person has in the group. So let's run our tests here and see what the result is. So as we can see here, if we have 7 candies and 4 people, the result is 1, 2, 3, 1. And I believe this is one of the examples from the question itself. Let's try the example that we did on paper. We did 9 candies with 4 people, and we get 1, 2, 3, 3, just as we did on paper. All right, let's go ahead and submit this. All right, so for runtime, we got 87.9%. And I don't know if my space complexity is just so horrible that it's not showing up here, or if it's just my internet that's not showing my space complexity. Anyways, I think I'm going to wrap this one up here, guys. If you learned anything new in this video, or you just enjoyed the process of solving the problem, please feel free to like and subscribe, and I'll see you in the next one. Thanks for watching. Bye.